All right, grade 7, we're on to a lesson 11.4, dealing with probability more in general. I think you'll find that this is a bit more of a friendly lesson than the last two have been. The other ones have been quite hard, which is why we did a lot of review with it. So I think you're going to find this one a lot easier. So we talked about probability at the very beginning of this unit, the chance of something happening. So before we were talking about how many different combinations are there, now we're going to talk about the chance of something happening. So the first thing we can do is we can talk about theoretical probability. And what you need to think about right now is really think about this word theoretical, in theory. Okay, so not necessarily going to happen, but in theory, there's a chance that something could happen. So we take a look here. We have theoretical probability is the number of favorable outcomes over, or as a fraction or divided by, the number of possible outcomes. So what I mean by favorable is this. Let's say I look at this spinner and I say, what is the probability that I land on blue? So in this case, blue is my favorable outcome. That's what I want to happen, okay? So the favorability or the probability of blue is this. If I look at my spinner, blue shows up once out of 4 times, okay? So the number of favorable outcomes is blue. It shows up 1 time out of the number of possible outcomes, which is 4. So the probability of me spinning a blue is 1/4. If I wanted to, I could put that into percent, 25%, okay? But it's theoretical. It doesn't mean that if I were to spin this spinner 4 times, 1 time would be blue, 1 would be purple, 1 would be green, and 1 would be red. It just means in theory, that's what should happen, okay? So theoretical probability is just a theory, what should happen. It doesn't mean it's exactly going to happen that way, but we can use theoretical probability to help us with different things. So let's try applying that to a different spinner. Here we have a spinner where we have 3 sections that are yellow, 1 that's green, 1 orange, and 1 is blue. So if I want to talk about the theoretical probability that you land on yellow, I could say, well, if I look at my spinner, 3 of them are favorable because 3 of them are yellow. That's what I'm looking for. And there are 6 sections on my spinner. So what I can do is I can actually simplify this. I can divide by 3. Okay, on the top and the bottom, you guys know that by now, and I actually get 1/2. So the probability of me landing on yellow is 50% or 1/2. What that really means is if, in theory, I spin my spinner 2 times, 1 of those times I should land on yellow. Okay, now let's take a look at this next one. What's the probability that I will land on red? Well, you're probably thinking, it's not. If you made a mistake, there is no red. So that's correct. What I want to show you is there are no favorable outcomes out of 6 possible outcomes. So the probability that I land on red is simply 0. It's not a chance, okay? So if I said to you, you can pick something out of my birthday box. If you spin this spinner and land on red, you're probably like, well, duh, Miss Nayef, you're not going to give me anything. Whereas you'd probably be happy if I said, well, if you spin the spinner and you land on yellow, I'll give you a prize. That would be the most favorable for you, okay? So if I gave you the choice of, spin the spinner, if you pick a color, yellow, green, orange, and blue, okay, we'll shorten it. Which one would you pick? Well, if you were smart, which I think you all are, you would pick yellow because it gives you the highest chance of winning a prize. All right, now let's take a look at this one, probability of green or orange. Okay, so if I look at my spinner, I have green and then I have orange. So how many favorable outcomes do I have? Well, there's 2 options that I could land on that are favorable out of 6, which I can simplify to 1/3. So the chance of me landing on green or orange is 1 out of 3. Again, this is just theoretical probability. It doesn't mean if I were to spin my spinner 3 times that 1 of the times would be green or orange. It means most likely that's what would happen. Let's talk about theoretical probability when we look at a dice. Okay, what's the probability that I land on 4? Well, How many favorable outcomes are there? There's only one. How many sides of the dice are there? 6. So my theoretical probability is 1/6. What about this? The probability that it's odd. Well, if I think about my dice, 1, 3, and 5 are odd. So that's 3 favorable outcomes out of 6, which I can simplify to 1/2. So the probability that it's odd is 1/2. Now take a look at this one. The probability that it is not 4. Probability that it's not 4. Well, if I think about rolling my dice, I could land on 1, 2, 3, 5, and 6. All of those are not the number 4. So that's 5 options out of 6. Okay, so this is what you're going to be seeing in your textbook. Probability of 4, probability of something, or probability of not something. That's how it's going to be written. Okay, so now let's talk about how we can apply theoretical probability. We can do that by predicting things. Okay, so if I take a look at my dice here, and I said, just like before, the probability of 4 is I have 1 favorable outcome out of 6. Okay, so the chance that if I rolled my dice 6 times, I would probably get a 4 one of those times. So I can use that theoretical probability to figure out, well, how many times would I roll a 4 if I roll my dice 24 times? So I know my probability of rolling a 4 is 1 out of 6. Okay, I know I'm going to roll my dice 24 times. So what I actually have done is I've set up a proportion. So I can use cross products, and I can do 24 equals 6n. I want to get n by itself, so I divide by 6, which you do to one side, you must do the other. I'm running out of room. Let's print attendance underneath. And I would get 4 equals n, okay, because I divided by 6 and I did 24 divided by 6. So going back to over here, my theoretical probability is 1 out of 6 times I would roll a 4, which now means that, I can put 4 up here, 4 out of 24 times I would get a 4 if I rolled 24 times. Okay, now remember grade 7, some of you like it better this way without cross products. Let me show you. Just as a review, because it doesn't matter which way you do it. It's entirely up to you. You could have this. You could have 1 out of 6 equals n out of 24. Some of you like to think, well, how did I go from 6 to 24? I multiplied by 4. What you do to the bottom, you must do to the top. So you multiply by 4 here, and you would get that n equals 4. Okay, so based on theoretical probability, we can predict things. Okay, we can go back to this slide here, and let's just erase a few things. So, let's do probability of yellow over here. I should have made my eraser a bit bigger. So, we figured out that the probability of yellow is 1/2. So, let's say I'm going to spin that spinner. I'm going to do it 300 times. Okay, how many times should I land on yellow in theory? Well, I can do cross products. So I can do 2n equals 300. I'm going to divide by 2 on both sides. And I get n equals 150. Which again, you might have just done that in your head. That's okay. So if I spin the spinner 300 times, most likely I would land on yellow 150 times, according to the theory. Okay, so now let's do one more with theoretical probability. Here I have a deck of cards, and I just wanted to introduce to you talking about or and then and with probability. So let's take a look at the first one. What's the probability that I land on an ace or a black card? So those are my options, aces or black cards. Well, what I can do is I can go to my deck of cards, which is nicely laid out. These are all black. There should be 13 in a row. Here's another 13. But I could also just have aces. So even though these ones are red, they fall under the fact that they are aces. So I have 13 plus 13 is 26. And those 2 extra ones, so I actually get 28 out of 52. Which if I wanted, I could simplify. Let's say I just want to divide by 4 or by 2, so I get 14 out of 26. Let's divide by 2, so I get 7 out of 13. So the probability of me picking a card from a deck that's an ace or black is 7 out of 13. But now, let's take a look at the next one. The probability, oops, here we go. The probability that I pull a card that is an ace and black. So now, what I'm really saying is I have to meet both of those qualifications. It needs to be an ace and it needs to be black. It needs to be both of those things. So if I look up here, well, here's an ace. It's an ace and it's black. Here's an ace and it's black. These two aces don't meet my qualifications because they're red. So it can't be or, it has to be both. So in this case, what I end up with is 2 out of 52, which equals 1 out of 26. Okay, so that's the difference between or and. So far we've been talking about theoretical probability in theory, but now let's talk about experimental probability. And experimental probability, you can just think of it as what happens if I actually do it? If I actually spin the spinner, what are the chances that something is going to happen? So remember we talked about the probability of blue. We'll do probability of blue in this case. Theoretically, it's 1 out of 4. Now, if I spin that spinner 4 times, I might not land on blue 1 time. I might land on blue 2 times or 3 times or no times. So this is where we get to experimental probability. So we have the experimental probability is the number of times an event occurred out of the total number of trials. So maybe let's pretend I spin my spinner. Let's do it 8 times, okay? So that would be my total number of trials. I spin it 8 times, and I land on blue 2 times, which I can simplify to 1/4. So in that case with my trial, my experimental matched my theoretical probability, but that won't always happen. If you think about flipping a coin, you have a 50-50 chance of heads or tails. It's completely equal chance. But just because you flip a coin twice doesn't mean one time you get heads and one time you get tails. The actual doing it is experimental probability. Okay? So I could spin my spinner, and let's say I spin my spinner. Let's make it a bit more interesting. Let's say I spin it 100 times. Okay, so that's the number of trials. So I sit there with my spinner, I spin it 100 times. And I notice that I actually land on blue 40 times out of 100, which is really, we can simplify that to 4 out of 10. We can simplify that to 2 over 5. So in this case, my experimental probability does not match theoretical, but that's okay, because just because it could happen in theory doesn't mean it will exactly happen. One thing you should notice is that if you actually were to do this, say spin a spinner or flip a coin 100 times, the more trials we do, okay, the closer our experimental probability gets to the theoretical, because it sort of balances itself out. If I flip a coin twice, I might get 2 heads, I might get 2 tails, I might get a head and a tail. But if I flip a coin like 1,000 times, I'll probably get pretty close to 500 heads and then 500 tails, because there's more chances of it balancing out. So let's take a look at how we can plot experimental probability. So here's my spinner. Let's say I spun it. I think I spun it 16 times. Okay, so that was my total number of spins. I can plot this information on a line plot. So I just did the colors down here. Okay, so I spun my spinner 16 times. So green showed up twice, red showed up 4 times, blue showed up 6 times, and purple showed up 4 times. So first, let's think about the theoretical probability of green. Okay, so theoretically, the probability of green is that it will show up 1 out of 4 times. Theoretically, in theory. Now, let's take a look at what actually happened. What actually happened is that the green showed up 2 out of 16 times, which I can simplify to 1 out of 8. So green actually showed up less in my trial compared to my theoretical probability. So my theoretical and my experimental probability were different. What if we did the probability of red? Okay, so again, the theoretical is the same. It should show up 1 out of 4 times. Now look at the experimental. It showed up 4 to 16 times in my trial, which I can simplify to 1/4. So in this case, the red and actually also the purple matched my theoretical probability and my experimental probability. Then you should be able to just take a glance and you should see that my blue actually showed up more times than I would have thought in my experiment or my theoretical. So my theoretical, same with the red, the blue showed up 1 out of 4 times or 4 out of 16. But in this case, the blue showed up 6 times. So I just want you to see that experimental does not always match the theoretical. All right, when you get to your lesson, I just noticed this as I was reading through your questions. Number 14 and number 16, it says look at the plot under construct meaning. You're going to find that construct meaning on the top of page 236. So for 14 and 16, the information you need is on page 236. Okay? So please no one chat with me tomorrow and say, Miss Naya, for 14, I don't know where they get the information from. It's on top of page 236, which is just the page to the left of your lesson. All right, I hope you find this lesson a little bit easier